We're going to talk a little bit about polynomial functions. So polynomial function is of this form right here. That form looks like just a bunch of letters and a few numbers, but it's probably the most common thing that you've seen in math. Mostly every function that we've dealt with so far in this class has been a polynomial function. So just a few little terms for you. The highest exponent, in this case, my n, so my highest exponent is called the degree of the polynomial. And the coefficient of the number that goes along with the highest exponent, I wrote it as an, that's called my leading coefficient. So those are important terms to know. You're probably not going to be tested specifically on these words, but they're going to come up again and again and again, so just make sure you know what they are. So for any polynomial, the domain is the set of all real numbers. So I'm going to give you the three most common polynomials, which I think you've seen all of these before. The first one is the constant function. That is a degree of 0. Those are the ones where you have like f of x equals a number. I have it written as a0. That's how your book writes it. Usually it's just going to be, it's basically just a number. It could be like f of x equals 3, f of x equals -8, f of x equals 1.1. Those are all constant functions. The graph of that is just going to be a straight horizontal line. The next one is a linear function. And those are the general lines in y equals mx plus b form. For example, f of x equals 5 minus x, f of x equals x plus 4. Those are all, anything that you've seen that's a line is a linear function. And like I said, it's a line. Quadratic function, another one that you've seen, those ones are going to be of the form, let's see if I can not run out of room here, a2 x squared plus a1x plus a0. Pretty much anything that's a polynomial that has a degree of 2 is going to be a quadratic function. So like if you have x squared plus 8x plus 6, that's a quadratic. Or if you just have x squared minus 3, that's also a quadratic. And that one we know is going to look like a parabola. So I'm going to give you a few vocabulary words that you may or may not have heard before. The first thing is a real zero of f. So that's going to be a value where that if that's your x value or your input value and you plug it in, you will get your y value or your function value equal to 0. So that value r, or that x value, is called a real zero. So there's a few things that will give us. We have a bunch of other words that we use for 0. We also call that a root. You're also going to see that. And I'm actually going to write down a few others. So if we say something is a 0 or a root, that means that that value is also going to be an x-intercept of the graph of your function. This one is really important. It also means that x minus r is a factor of our function. And then our last thing is that r is a solution to f of x equals 0. So all of these things are equivalent. And actually, one thing that's going to really help us is we are going to be able to graph a polynomial and find its equation if we know its zeros. So we're going to start with an example. For this example, we would like to find a polynomial of degree 3 whose zeros are -4, 1, and -5. So actually, all we need to do for this one is write out the factors so we know that our three factors are going to be x plus 4, that comes from this -4, times x minus 1 times x plus 5. Keep in mind that the signs in when it's in factored form are actually the opposite of the 0. So I am going to tell you that this is not the only polynomial of degree 3. You can also have something where you have like a 4 in front of there. You can have something where you have a -8 in front of there. You can have pretty much any number as a coefficient of this. So there's a lot of different polynomials that are possible. But since they said find a polynomial of degree 3, that kind of implies that we only need to find one of the possibilities. We do not need to find we do not need to find a specific one. So there's many answers for this. This is probably the easiest one though. So to be honest, if you gave me an answer like this on a quiz, I would give it to you. But I think it's a good idea to just practice simplifying these out because sometimes people are still having problems with these. I think that practicing algebra is really, really important because when you take calculus, you're gonna really want those algebra skills. It's gonna really help you. So are you gonna use the FOIL method? You're welcome to fast forward through and just do this on your own if you want. But I will go ahead and work this out. And if you are confused about any of the steps I'm doing, you can just ask me in class, ask me individually. So make sure that you do multiply every term in the first factor by every term in the second factor. There's so many places that you can make mistakes, so I do recommend that after you finish simplifying this out, you go back and you check to make sure that each 0 actually works out. I'm going to be completely honest with you. I actually went back and checked and I found that I had 2 mistakes in this. Hopefully this one is right. So you can plug in the -4, the 1, and the -5. That hopefully should help you catch if you made any algebraic mistakes, because there's a lot of places that you can just miss something. So I do recommend doing that. Oh, and I do want to mention that this is a degree 3 polynomial. If it hadn't said that, you actually could have added as many factors as you wanted, but it told you degree 3, which means you should have an x cubed in the end. In factored form, a polynomial of degree 3 should have 3 factors. Or if you have, I am going to tell you one thing, you don't need to write this down, but if you have something like that, where you have a squared in there, that would also be a polynomial of degree 3. So for our second example, we're actually going to find an answer that is the only answer. There's only one possible answer for this one. You might notice instead of it's saying find a polynomial, it said find the polynomial of degree 3 that passes through the point -4, 16 and has zeros at -2, 0, and 2. So we're only going to have one answer here. There is a coefficient. We need to find our coefficient. So I'm going to show you how we'll write it. We are going to start off with f of x is equal to a, this will be the leading coefficient, times x plus 2, remember this comes from my -2, times x minus 0, times x minus 2. I'm going to use black just in case this doesn't show up on YouTube. So, sorry about the different colors. What I'm going to do is I'm going to write a here. X minus 0 is just going to be x. That actually is going to make the problem much, much easier. Times x plus 2 times x minus 2. You'll notice I haven't actually multiplied it all out yet. I'm doing that on purpose because it might make the problem a little bit easier. I'll show you why. So now we need to figure out what a is. So we're going to find a. In order to find a, we need to use that point -4, 16. So I'm going to make it 16 equals a times -4 times -4 plus 2 times -4 minus 2. So if I multiply all of that out, or if I simplify that, I get this right here. Then when I multiply it out, I get 16 is equal to a times 8 times -6, which gives me -48. And so if I divide both sides by -48, I should end up getting a equals -1/3. So it's not a really nice or pleasant number, but it is going to give us our exact answer. So now that I found that, I am going to rewrite this as f of x is equal to -1/3 x times x plus 2 times x minus 2. Thankfully, if I want to simplify it out, which we're going to do, it's not really that bad. You might notice that x plus 2, x minus 2 is a difference of squares, so we get x squared minus 4. And then if we simplify the whole thing out, we multiply x squared and 4 by -1/3 x. I just end up getting -1/3 x cubed plus 4/3 x. And again, you can go back and double check that you're going to want to check if you're checking your answer. You want to check to make sure that -416 will go into this and will work as a point. And you also want to check that if you plug in -2, 0, and 2, you do end up getting 0. So that would be if you have a little bit of spare time on a test or quiz, I recommend that you do that. So I'd like to quickly talk about multiplicity. So if you have a factor that occurs more than once, we call it a repeated or a multiple zero of your function. And we know what the multiplicity is based on the exponent of the factor associated with the zero. So if you're super confused right now, that's fine. I'm going to give you an example or two. So here's a polynomial. I will talk to you about zeros and their multiplicities. So you'll notice here, the first one I have here is x squared. Keep in mind that if I just have a plain old x, it's kind of the same idea as if you have like an x minus 0. So in that case, I have a 0 at x equals 0. However, you'll notice it's squared. What that means is that I have a multiplicity of 2. For this middle one, x plus 2, for that one, my 0 is -2. I don't have an exponent, but you can just imagine that there is an invisible 1 there. So for that one, my multiplicity is going to be 1. And then this last one, my 0 is 1/2, and the multiplicity is going to be based on its exponent, which is 4. The last thing I want to talk about with multiplicities is that if you add together all of these exponents, that will give you the degree of the function. So you don't actually have to multiply the whole thing out to find the degree. Remember, the degree is the highest exponent. But you don't have to multiply everything out. You just need to add together the exponents. So we get 2 from the 5x squared, from the x squared. We get 1 from our middle term. Don't forget about that. And our last term has an exponent of 4. So that means that our degree is 7.